Hello and welcome. This is a lesson on the sun. Get ready to learn. The sun is coming out. Did you know that our sun is a star? Many other stars in the universe. Ours is an average star. All planets in the solar system, our solar system, orbit the sun. Many other things do too. Comets, asteroids. Most of our energy comes from the sun as electromagnetic radiation. That's how it transfers from the sun to the earth. It's not just light. Why is this important? Well, most of Earth's energy is from sunlight. A very small part of it comes from nuclear power. The rest, sunlight. Plants need sunlight to grow. So by understanding how the sun works and the sunlight, we can best grow plants. The earth is heated by the sun. It's heated not in a uniform way. Water heats at a different rate than rocks, land. That creates weather and wind, and we'll talk about that some other lesson. Civilizations have worshipped the sun. It gives life, gives light. What's important to know about the sun? Well, it's the largest thing in our solar system. 1 million Earths can fit inside. Now, of course, that's not going to happen, but just to give you an idea of how huge this thing is. The massive gravity pulls planets in towards the sun, and planet inertia keeps them in orbit. Inertia is the tendency to go in a straight line. Now, the sun is in the center of the solar system, so you have gravity pulling in one direction and inertia going in the other way, and that creates the orbits. It's in the center of the solar system and emits light and other kind of electromagnetic radiation. X-rays, gamma rays, all kinds of particles spit out by the sun. Now, it takes 8 minutes and 20 seconds for light to reach Earth from the sun, and that's at the speed of light. Sunspots. They appear because the rest of the sun is so much brighter and hotter. So this area here would be hotter than this area here. Solar flares are often followed by large ejection of plasma. It's called a coronal mass ejection. And you can see this whole ball of hydrogen and helium is erupting. It's just exploding all the time. And it gives out all kinds of radiation, but also particles are thrown in. Here, I'll show you. Look at this. Thrown up from the surface. What's important to know? The sun is huge. Look at where we are compared to the size of the sun. It contains 99.8% of all the material, all the mass in the solar system. Almost all of it's in the sun. I did mention that we're this little speck right here. Tiny. About 1 million Earths can fit inside, and it's 865,000 miles wide. The diameter is about 110 times the diameter of the Earth. This thing is huge. It spits out material all the time, has for centuries, and will continue for centuries. The sun is just another star. Nuclear fusion converts hydrogen to helium. All this material is hydrogen, and when you smush or mash because of gravity, all this, the atoms of hydrogen together, you form helium, but you release an incredible amount of energy. There's enough fuel for another 5 billion years. When that's used up, it'll swell to a red giant, which is another kind of star. But I don't know that I'll be around. Eventually it will collapse and become a white dwarf, a different type of star. And in the final phase, it'd be dim, cool, black dwarf. But that's way, way in the future. Nothing to worry about. And the thing to remember about the sun is it keeps ejecting material into space. There's so much there, though. It's not going to run out for a long time. Now, the sun's made of layers. The core, right here, it's in the center. It's about 24 million degrees Fahrenheit. It's hot. It's mostly made of hydrogen, 74% hydrogen, helium 24%, and that leaves 2% for the other materials. Typically, oxygen, carbon, iron, and neon make up the remaining 2%. It generates huge amount of energy by combining hydrogen nuclei, the center of the atoms, into helium. The electrons are stripped off way long ago. This is called nuclear fusion. Fusion is to put together, to make a union of two atoms. Now, the sun has an atmosphere, believe it or not. The photosphere is the visible surface of the sun. Okay, we got the photosphere here. It's the visible surface of the sun. The chromosphere is above the photosphere. That's here. That's where sometimes gas jets fly up and solar flares. And then you have the corona. Think of the word crown. It's a halo or crown extending millions of miles into space. So the sun does have an atmosphere. It's not one I'd like to be in. Now, the sun also has seasons. Just like the Earth goes through seasons, sunspots are cooler areas of the surface and appear every 11 years. Why? Nobody knows. But if you plot these things, you'll see that every 11 years, you have sunspots. These are cooler areas, and they appear on the surface of the sun. Nobody knows why. Now, solar flares send high-energy particles into space. It takes them, they're not traveling at the speed of light, so it takes them 2 days to get to Earth, which gives us a window of opportunity because we can see them before they affect us. We have 2 days to react. Solar wind disrupts satellite communications. That's what we're talking about here. High energy particles, solar wind. And it's dangerous to astronauts, causing cancers and low blood counts. So when this activity happens, we have 2 days' notice to get our astronauts, if they're on the space station, into a high protected area so that they're not affected and they're shielded from these energy particles. Sun rotates. I know, it's hard to imagine, but it does. It's a ball of gas and plasma. It does not have to rotate rigidly. It's fluid. Not like liquid, but it changes. The equator regions rotate in 24 days, and then the polar regions at the poles rotate in 30 days. So it's kind of stretching itself around the poles. It's very interesting. And the axis is about 7.25 degrees. So let's see, if that's 0, that would be about 7.25 degrees off the plane of the ecliptic. If you put the sun and the planets on a table, that would be the plane of the ecliptic. And this is not straight up and down, it's slightly off. Now, solar eclipses allow for the corona to be seen. This is rare, but when it is the sun and the moon and the earth in line, there is the umbra, where you have the shadow cast by the moon on the earth, and when that happens, the corona of the sun can be investigated. It depends on the positions of the sun, moon, and earth. It's rare. But the corona extends for millions of miles, and it's so nice to be able to see that directly. That's what it looks like. This is the corona. Here's the moon. Why is this important? Most of the Earth's energy comes from sunlight. Plants need sunlight to grow. Earth is heated by the sun. The more you know about it, the better you can be. Civilizations have worshipped the sun. It's important to understand our universe and our place in it. Hope you've learned something.